the recorder, and let's start the process of moving forward. Good morning, ladies and gentlemen, and we are going to continue with the next topic, which is a discussion on embedded SQL. Now, I'm not sure how many of you have used embedded SQL, but please, in this particular case, if I say anything that you disagree with, please let me know, and we can have a discussion on the matter. I use SQL to create databases, to create logical views, and I embed some forms of SQL into RPG programs because in a lot of cases they are easier to use. Now, this is just to trigger a discussion or to start discussing the various aspects of embedded SQL. I've just got a little bit of sample code that we can talk around for a while. This is very typically what I use embedded SQL for most commonly, and that is to select records, specific records from specific files, particularly to build lists and filters. In fact, all the filter functions that you will see in AO are all built using embedded SQL, and the reason for that is quite simple. They are easy to construct. You can concatenate variables in them, or what they call host variables. And the way I normally do it is I actually create a SQL statement by concatenating the bits together. There's a SQL string that was actually pre-established in an earlier program and passed through as a variable. Here is the order by sequence, which was also pre-established in an earlier program. And that's the big advantage of this. You can actually concatenate bits of your SQL statement together and then concatenate them into a variable, which I usually have. It's about 2,000, 3,000, 4,000 bytes, depending. And so I build my SQL statement into a variable. So the first SQL statement I then execute is to prepare a statement, the SQL statement, which is that one. You give it a name. And again, as you can see, we fall into my naming convention once again. I use the same style, statement one, and you prepare it. This is basically almost a compiler. It prepares the SQL statement after you've concatenated the variables into it. In some cases, you can designate host variables directly in a SQL statement. Pardon me, but most of the time I do it this way. I find it neater, tidier, and easier to read. I then declare a cursor for the compiled statement. This is basically just a cursor, which is a record pointer based on the 130FS1, which is the statement that I prepared, and then I open the cursor, which is equivalent to a file open. So those are the statements one needs to prepare a statement and to actually open a SQL statement inside RPG. You must remember that when you do this, the source has to be RPG, SQL RPG ILE. It has to be a SQL source, SQL stroke RPG source. It can't be the typical RPG LE source, because the compiler treats this differently. It behaves differently, and it embeds a lot of stuff in the source, and then it precompiles it to get rid of all the SQL statements, which it comments out, and replaces them with RPG statements and calls to other procedures, and then it compiles the program as RPG. So you need to have the right source type for this. Right, now the sort of do loop, when people first see this do loop, they get all excited because they don't really understand what I'm doing. But this is actually an endless loop, and it gives me total control of when I want out. So I use it quite a lot. It's a toy I have. Right. The next exec SQL statement is the fetch. So basically you fetch a record using that cursor, and you fetch it in to a host variable, which is a data structure. It has to be a data structure, and it has to match the 130F file, or whatever file it is that you are reading. You're selecting from 130F. So this is a data structure that has to be based on 130F. If it's not done that way, the SQL statement fails because it hasn't got variables to put the values into. So using SQL in this way means you are selecting all, that star over there means you're selecting all fields from 130F. That means all fields in 130F must be present in this host variable, which is the data structure. Otherwise, you cannot read or fetch that record. So what we are doing here is we're basically doing a read as if we were doing a read in RPG. This is exactly what it is. Right, and this is where I want to introduce you to something with SQL, because SQL has a different way of reporting errors. Now remember, this fetch is in fact a standard I/O. It's a read. It may fail. It may reach end of file. There can be many possibilities in terms of this getting an error. But the standard monitor on error end monitor group that you have seen me use on a number of occasions doesn't work for errors encountered by SQL. Because there are two. There's the SQL code and the SQL there's two indicators that come back. SQL code, and now I've got a blank on the other one. Somebody help me. And they come back with funny numbers. Negative numbers mean you've got an error. Positive numbers mean you've got a warning statement, and a 0 means that the thing was successful. SQL state, thank you, Ed. State and SQL code. Those two define what has gone wrong with SQL. However, you cannot catch those with a monitor on error end monitor group. And this irritated me, to be quite honest with you, and it was one of the reasons why for a long time I didn't embed SQL. I actually used open query file in CL programs, because at least I got a decent error message back a normal error message back when something went wrong with the open query file. However, not so long ago, I discovered something, that both the SQL state and the SQL code are embedded in a data structure called the communications area, which is a data structure which is embedded into a SQL program. Now let me see if I don't have a precompiler, a precompiled source of a SQL program. But let me just see if I can find because this particular example that I have, I unfortunately left out the structure, the D-specs. So I'm just looking for something. Here we are, find it here. This program, which is one of the AO programs that loads lists, you will see it's an SQL RPG LE type code. It's specifically because it carries embedded SQL. If you have the wrong type code, if you have the RPG LE, it won't compile. Now, what I did is I created, this is not going to give me what I want. All right, while I'm talking, I will look for that, because fortunately I can do that. I added a procedure to the error handler. And in fact, it is, if I can find it, no. I've got to get into here. That's what I want, where I want it to be. And I'm going to just open up the ILE RPG. This is part of the open source that I provided for the error handlers. And I discovered something. This was the latest addition to the error handler suite of procedures. It's called ERR50, and it converts the SQL code to an error message, to an actual IBM I RPG error message in exactly the same style as the normal error messages. The way it does this is I discovered there's actually a message file in the IBM I with all the SQL error messages in it. And you can convert the SQL code and SQL state. Using those two, you can convert them to an error message that is defined in the error message file on the IBM I. As a result, and the file, let me see where it is here. This is the code. It's actually called QSQL-MSG, which contains all the SQL error messages in a rather nice, QSQL-MSG, if we can look at it here, work MSGD space, QSQL-MSG. This is the message file that contains all the SQL errors. And the numbers and the prefixes relate to a combination of SQL code and SQL state. As a result, you can convert these rather difficult to read cryptic numbers that SQL returns to you into a reasonably user-friendly message. And so I added this as a routine into my error handlers. And it's ERRH 50. And you can see it uses the communications area. So it receives a pointer to the communications area. There's the communications area based on CA pointer, which is passed as a parameter. It then returns an indicator. Where am I? Here we are. It's a function, so it's returning an indicator, which is off if record was found. If record was 100, it returns an indicator of on, because that is an end of file indication. And if SQL is greater than 0, it returns an off, which is a non-terminal warning. If it's negative, it converts it into a decent SQL message and returns that ERR11 is an escape message. So it actually returns it from this routine as an escape message. So what we do and how you use it, where am I? There we are, is after each SQL statement in which you want to test to see whether you have a successful read, you use this if that should be ERR, I have to change that, 50, and you pass it the pointer to the communications area for this program. This is to set list all, this is to do something if the indicator is on, which means it's end of file, and you leave. If it's not end of file, you can continue with your processing. It's not too much of a concern as to what that processing is, but remember that if this error handler finds a negative SQL code, which indicates that an error has occurred, it will convert it to an IBMI message, and it will then return it as an escape message. So it will automatically drop from this line here straight into the on-error condition of your monitor group. So if there's an error on that call there, let me just change my pointer to a highlighter. If there's an error, pointer options, ink color, red. Now that's not very working either, is it? Let's erase the ink. Let's go to the pointer option and use a pen. There we are. If this call to that procedure fails, i.e. an SQL error was encountered, then it will drop to the on-error condition. It will bypass this. It will bypass any other processing that you have. And in fact, your on-error condition will follow this loop, so it will drop straight out of there, straight down to your on-error condition, which should be somewhere around about there. So this does two things. First of all, it takes the numeric number that is the SQL code or SQL state. It converts it to something readable and then passes it out as a normal error message that we've been talking about all along in terms of percolating errors. So this handles SQL errors. And this is the most important thing about embedding SQL, is you have to handle the SQL errors. that occur, and they will occur. Whatever SQL you embed is going to create an error potentially, and you must handle them in exactly the same way as you would do for errors which occur inside the normal RPG environment, such as constraint errors, trigger errors, and various other errors that occur inside the RPG. And utilizing this little procedure, you can actually handle them in an identical manner. And that's where this was a huge success for my evolution into embedding SQL, because I can get the errors to be handled accordingly. Of course, once you finished your loop, you close your cursor and then set on LR and return if you want to exit this particular routine. However, that set on LR we're going to cross out, because that doesn't happen anymore. Because we don't set on LRs for things. Those are recovered by the activation group exercise. So this is an embedded SQL inside an RPG. It's designed to load records into a list or a subfile if you're using display files. And I can change the order there by changing that. I can actually change what is included in the list by changing that statement, which is a simple SQL where clause. I'm looking for another list. I usually use these in list loaders. There's one that actually is being in use. Here is my, in my initialized subroutine, I set up SQL1 by concatenating a selection that I want to use. And I then set up the SQL select. Add the order by. You can do it in one statement, multiple statements. You can spread it out all over the place. I then prepare the cursor, declare the cursor, and prepare the statement, declare the cursor, open the cursor. And then I would go back here and fetch. As one of the examples, fetch, and here you can see that I have the CA pointer is initialized as the address of SQL CA, which is the SQL communications area, which is precompiled into the source. You don't have to even specify it, but it is precompiled into the source, so you can pick up the address of the communications area. Now, the important thing about that is it passes the pointer to the error handler routine. There is the communications area. You see it's based on the CA pointer, and CA pointer comes from the parameter that was passed through into the call. So this is the SQL communications area where both the code and the state are available to this routine in order to decode that. So you can see here is the, if that condition is true, there's no record, otherwise you can carry on. As you will notice, in this case, I have a monitor group, on error end monitor, and if that condition there produces an error, I will drop into here and I will percolate that error out to whoever needs to deal with it. And it will be the SQL error, but translated into a a human readable format. Like this. Value not valid table or file specified more than once, etc., etc. All of these are SQL error messages, and they all, by the way, as a matter of interest, I think most of them, let's just have a look at this, 5 to display the details, and 1 for the message text. They have a message. That's the message. They also have a second level message, which is exactly what is available in the normal operating system by putting your cursor on the error message at the bottom of the screen and pressing F1, you get the second level message coming out. So your SQL error messages have now got a lot more body to them, which is very useful from a user perspective. You don't have to try and tell the users what -501 is, or what -401 is. Okay, so embedding SQL, you need to know SQL. If you don't know SQL, you can't really embed it, because you're going to get it wrong. All SQL statements begin exec SQL, and they end with a semicolon. And between there and there, you can have a SQL statement. And I have been shown an RPG program which has one SQL statement that is 14 A4 pages long. That is 14 pages between exec SQL and the semicolon. 14 printed A4 pages, 14 of them, with one SQL statement on that lot. I would suggest that you don't do that, because you might be a SQL expert, but the people who are coming after you, who have to maintain this sort of thing, may not be SQL experts. They might be RPG experts. Now, keeping it simple, it's readable with simple SQL. Get too complicated, and you can create all sorts of difficulties in maintaining your code. The other thing which SQL is often used for inside RPG is when you build a SQL view, as we discussed, you can join multiple physical tables together, and you can create a view of the database that can be quite complex. But you can't order it. It's a permanent object, it's available, it doesn't occupy space, but you can't order it. So embedded SQL can be used to place a key or a sequence on top of a view in order to be able to process it. Okay, I'm going to ask at this point, are there any questions? Because this is all I'm going to do with embedded SQL. Yes, you can read a lot, you can Google a lot, and you can find all sorts of things about SQL. And you can try them. But one of the things you have to be very, very, very careful about is that, and one of the things that was actually highlighted to me a number of years ago, is if you wish, for example, to use a select SQL statement to extract a certain set of records, based on a host variable. And you want to do this in 2 or 3 places in your program, using different values in the host variable, but nevertheless, exactly the same SQL statement. If you write that SQL statement in 3 different places in your program, you will end up opening up 3 different open data paths. I didn't go into too much depth about this, but it horrified me to hear somebody say that that can happen. And the answer is, if you have that type of situation, put your SQL statement into a procedure and then execute that procedure, because a SQL statement that's executed 3 times from the same location in the RPG program only uses 1 data path. Don't understand it? Don't know at this point in time whether it's 100% true or not. I'm passing on something that somebody told me. And that's why, if you're going to use SQL statements, it's a good idea to put them in procedures, so that if you reuse the statement, you reuse it from the same place in the code. Okay, any questions that I might need to answer at this point? Embedded SQL is an important part of modernizing your code, because it can do things quickly, cleanly, and easily. You don't need fspecs. And it's particularly valuable for looking for sets of records or that sort of thing. So yes, it is a good tool, but be careful how you use it. Because no matter what anybody says, the very fact that it has to run a precompiler and it embeds a whole lot of objects into your source code and then replaces the SQL statements with calls to SQL routines will always introduce some degree of performance overhead. So use it in a simple form, but if you get more complicated, check to make sure that you are optimizing the performance, because it could have a very negative effect on the performance of code instead of the expected improvement. All right. No questions. I'm moving on. Here's a family of baby elephants for you to shame over for a while I just get my thoughts in gear. Right. The next topic I want to cover, and please, if you have any statements or any questions about the SQL, please send me emails. Here's a question from Ed. Well, you will reduce the size of the program just by getting rid of the cycle code. The program size will increase to a small degree using SQL, because it's now embedding stuff into the source, but it's hardly noticeable, Ed. There's a couple of data structures, a couple of prototypes, and various calls to different procedures depending on the SQL statement. So it may not create a larger program size, but it could affect the performance. Okay. Right, let's move on. We are going to look at something which a lot of people overlook as part and parcel of modernization of your RPG code: application programming interfaces. The explosion of APIs. When I first started writing RPG for the AS400 many years ago, there was one manual And there was actually about 3 chapters in that manual which documented and explained probably 20, 30 APIs at the most. These days, we will show you, I haven't downloaded all my APIs for application programming, but there are about 20 odd volumes. There's one there, object APIs, security related APIs, software product APIs, and so on and so forth. There are about 20 manuals in their own right, which you will find in the info center, to deal with different types of APIs. APIs have been grouped. There are now well over 1,000 APIs. Here is the programming API overview and concepts manual, which you can get from the info center. And it's a very, very good start to understanding APIs, the concepts of APIs, how to use them, and so on and so forth. The power behind APIs is that they allow you access to parts, information, and bits of the operating system that you have no other access to in any other way. Particularly CL commands that begin RTV, retrieve. They are all covered by APIs. Let's move on and have a look at some of the details. And that is the APIs and the thousands of APIs that are available now. I can't find my cursor. Where's my cursor gone? Okay, there it is. Oh, it's not a cursor anymore. It's still a... Let's have the arrow. There we are. To use specific data or functions of the IBM OS operating system. These are windows into the OS, which you can't get in any other way. You have to use your APIs. IBM intends that APIs will continue to work as they originally worked, and any existing applications that use the APIs will continue to work without any incompatible changes in future releases. Significant architectural changes, however, may necessitate incompatible changes. This is a statement by IBM about APIs. And I have been using them extensively since the year 2000, maybe even before that, 1998, somewhere around there. And I have never yet encountered the need to recompile a program or redefine the use of an API because of an operating system change, release, or version change or release. So this is a significant statement. And this and the concept behind them, because it's a very, very good way of handling your own parameters when you write your own enterprise servers and input-output servers to use the same parameter concept that the APIs use. Won't do you any harm whatsoever, because it's stable and it allows you to continue enhancing your APIs without the need to go and rework programs that are using them. So this is a very important statement. Some API definitions, such as the Unix type of API definitions, are established by industry standard organizations where the degree of compatibility is determined by those organizations. And this is also a very, very important statement to remember. There are some Unix-based and some C-based APIs that are available for use within the RPG ILE environment because ILE stands for Integrated Language Environment. And therefore, the IBM I supports APIs written in other languages, such as Unix, C, and all the rest of it. However, the guarantee up here, the second block in this, that IBM issues, only applies to IBM I type APIs. They cannot guarantee the Unix or the C-based APIs will not suddenly change based on an industry standard that they have no control over. So be warned when you use APIs. If you choose to use some of the Unix type or C type APIs, which have some capabilities, I have to be honest, they have some capabilities that the IBM I APIs don't have as yet. And I say as yet because the number of APIs is continuing to grow at an alarming rate. So just be careful to understand that if you use the non-IBM I APIs, you could have issues with their usage in the future. All right, let's have a closer look. An application program interface functions by the operating system or a separately orderable license program. Some of the separately orderable license programs come with their own set of APIs. Allows application programs written in high-level language to use specific data or functions of the operating system or the licensed program. So APIs are designed to allow you to use bits of the operating system that you would otherwise not have any access to. You have got access to some of it, and this is where it is. Some APIs provide the same functions as CL commands and output file support. Some APIs provide functions that CL commands do not. And most APIs work more quickly and use less system overhead than the CL commands. Fourth one. Some APIs have no equivalent CL commands, i.e. you get more from the API than you do from the CL command set. And it was this movement, this growth in APIs, that took me completely away from CL as a programming language. I didn't need to use CL to do some of the stuff anymore because I could do it with APIs. And very often, my normal approach is, as you can see if you've looked at the error handlers, is to wrap system APIs in my own enterprise services APIs or procedures, so that I'm using the system APIs but embedded in my own. And that makes parameters simpler, handling simpler, more consistent, etc., etc., etc. So the APIs can and will become part of what you do in the future. Now, a lot of APIs, let's go on to the next click, because sometimes I tend to talk. They provide better performance when getting system information and when using system functions that are provided by CL commands or output file support. This is another thing. We used to, and I'm pretty certain that there will be somebody or some systems that the people I'm talking to have, where you used to run a CL command to produce a printer file output, which you then used to copy to a physical file and process from there to get information. And then when the operating system changed the output, because they wanted to add stuff, you had to rewrite the whole thing. If I'm wrong, tell me so, but I'm pretty certain that every single one of you out there has got something like that in your system somewhere. That is definitely not a good idea when modernizing your system, because that is a potential hazard forever. APIs provide system information and functions that are not available through CL commands. I'm saying the previous slide the other way around. You can use calls from high-level languages to APIs, i.e. you can use RPG to drive APIs. And you can access some system functions at a lower level than was initially provided on the system. So, is there more? Yeah. Data is often easier to work with when returned by an API. And the reason for that is that APIs return information in user spaces. APIs return information in user spaces. Now, my next topic is entitled User Spaces and User Indexes. And we're going to talk specifically about user spaces so you can understand how they work and what you can do with them, because a user space and a user index replace arrays, they replace all sorts of other techniques that we used to use to manipulate lists and printouts and all sorts of things. But they do them so much simpler, so much faster, and so much more efficiently than any techniques we used before. Now, APIs mainly give you access to operating system functionality. So there may not be, it depends on what your application is and how it works, as to whether the APIs are going to provide you with enormous capability or not. But don't discard them, because APIs can tell you, for example, what jobs are active, what jobs are sitting in a job queue at what state, what files are sitting in a spool file. All of these things can make your actual application much more self-reliant and self-sufficient if it can access the information that the system has about things that are going on around it. For example, if you want a batch job to check first to make sure that it isn't already running, that's something an API can do for you. At the moment, what happens is we actually tend to run into a problem, run the job, and it crashes, or one of them crashes. So don't, just because APIs tend to be operating system orientated, don't discard their usefulness. And really what you need to do is you need to get the manuals and work through them. You can work through the index at first and look for ones that are interesting, and then take it from there. Go and look and see, and just be aware at all times that APIs can provide you with an enormous amount of power. Right. Let's just look at some of the terms. Binding directory. Well, we've talked about that. It contains a list of names of modules and service programs that is used to bind stuff together. A data queue, an object that is used to communicate and store data used by several programs in a job or between jobs. This is red because it is replaced much more efficiently by a user index or a user space. Module, we've talked about modules until we're tired of those. Program, service programs, user indexes and user queues, User queue is an object consisting of a list of messages that communicate information to other application programs. Only programming languages that use the machine interface can access user queue objects and a user space. These are some of the things that words you will see. But the two red ones, user queue, data queue, are replaced by the user index, user space, and so on and so forth. Is what we're going to be looking at next. But I just want to now have a quick look, if I can find it. Here we are. Actually, what I'm going to do is I'm going to use the my IBM Knowledge Center. Now, because I'm writing a product that really at the moment is running on 6.1, I have my Knowledge Center set at 6.1. I don't know whether you guys have got this particular URL as a favorite on your browser, but you should have. You can pick up the different versions that you want depending on where you are. Table of contents comes in on the side here, and if I scroll down here to plus on programming, and there is a section on application programming interfaces, and this is APIs by category. Now, these are the categories of APIs. Now, I said to you that there are a lot of APIs. These are the different categories of API. And this is where you need to begin to start looking, because you're going to find a lot of things in here. Backup and recovery, client managed cluster, communications, configuration, maybe not so much. Cryptographic services. Interesting. There are some cryptographic encryption and decryption APIs, authentication APIs, key generation, key management. So as we move into this sensitive area of sensitive data, encryption and decryption is most powerful. And there are APIs that do this, and they do it very efficiently. What else? We have database date and time APIs. Now, a lot of these date and time APIs have been replaced by built-in functions. But they also have their advantages, because you can retrieve system time information, including the current coordinated universal time and time adjustments information, something you can't get any other way. So each one of these has its uses. These, by the way, these four at the bottom here, are the C and Unix type time APIs. They're separated from these. Okay, so that's another set of APIs that could be useful. The debugger, dynamic screen manager, edit function. It goes on and on. There's your ILE, CEE types. Those are CL, I think, date time, activation, group, and control flow APIs. You need to go through this because there is a lot here. There are thousands of APIs at the moment. And you need to at least have some idea of what is available to you. Message handling APIs. Most of my error handlers are based on those message handling APIs. National language support, object APIs, i.e. access to objects, list of objects, and so on and so forth. And so on and so forth down the list of APIs. What I'm going to do is I'm going to open the object list of APIs and use object-related APIs, because we're coming back to a couple of others. Because I want particularly not so much to illustrate the actual API function itself, but to illustrate how the API returns lists. Some APIs will return a single set of information, and other APIs return lists. And it would be a very good idea to take one or two of these APIs, like this one here, Q, USL, OBJ. This returns a list of objects. And not so much, you might never want to pick up a list of objects out of a schema on an IBM I. But the structure and the method that is used to return this list information might be a good basis for you to return lists of information for your enterprise service procedures. And if you base the whole functioning of your enterprise services on the way the APIs are structured for the operating system, you won't have a problem, because it gives you a huge amount of flexibility and a lot of capability. So I'm going to just do a list of objects to show exactly how the API is handled. Now, understand that the call to an API is actually a program call. It is not a procedure call. The APIs are programs, and it's done with a program call. So the actual prototype says EXTPGM, and you then have your object name. Let me see if I can get back here to here and here. Sorry, I'm looking for a couple of things like the error handler module. Let's take this one here. This here is the prototype for the send program message, which is used by my procedures to send program messages. So it's embedded in my enterprise service, which is my error handler. And this is often what happens, what one does. You handle and utilize the APIs within a code that you yourself then control. And you can see the call is there. That's the call. And some of these parameters are hard-coded, others are not. That's also a technique to reduce the number of parameters one has to manage. So let's have a look at this particular, I know what I wanted to show you about this, is that call here, this send program message, if you have a look at the prototype, you will see it's actually an external program call. It is not an external procedure call. So it's a program call. APIs are programs. Okay. Parameters. There's a required parameter group on all APIs. This is usually the list of parameters that was required when the API was first published. And this is a trick which you need to use in your enterprise services to make sure that if you want to enhance your enterprise services, that you do not have to recode and recompile dozens and dozens of programs. And this is why I stress this particular process altogether. When you start thinking about enterprise procedures, you can use the same concept. Your enterprise procedures are actually procedures, and they're bound into service programs. So they are a procedure call, not a program call, but you can still use the same philosophy. And that is the important thing. So the first parameters, or the required parameter group, is usually those parameters that were put in place when the API, or in your case, your enterprise service, was first designed and structured. You design your enterprise service by saying what you want it to achieve, what's its purpose, what's it going to do for the application. Then you decide what output it's going to provide, and then thirdly, you work from the middle to both ends. You decide what input it's going to need to produce the required result. That's how you specify an enterprise service. And the parameters are then defined. Now, I'm not going to go into too much detail about what these parameters are. Notice they are input parameters. This means you are passing these parameters into the API. You're not getting anything back from them. These are one-way parameters. This is information going into the API. Optional parameter group 1. They enhanced this API at some point in time, and they created an optional parameter group containing an error code parameter, which was actually an I/O parameter, i.e., you could pass information into that parameter, and it would return you information on return from the call. Now, I'm talking about a system API, but I could just as easily be talking about an enterprise service that you are busy designing or have designed. Notice that this error handler doesn't have a specific length. It's a character, but it has a star. This generally indicates that it can be of any length. It's a varying parameter, and in this particular case, it actually comes back as a data structure. The error code is all over. It's actually detailed, described somewhere else. So this is a parameter that you pass in certain information, telling the API what you want to do with any errors. And then if there are errors, it returns information about those errors in the same parameter. Right. Optional parameter group 2, a further enhancement. Authority control and selection control. Obviously, we're in a list objects API, so these have something to do with selecting by object and other selection controls. Notice these are inputs, and they are starred, which means they are variable length. And then there was a third enhancement, or fourth enhancement, that actually added an optional parameter group 3. Auxiliary storage pool control. Same again, input variable. Now, these optional parameter groups are required or are managed by the API itself. I.e., if you do not specify those parameters, The API will recognize that they have not been specified, and I showed you, I think it was last session or the one before, that you can use the percentage palm built-in function to determine how many parameters there are. And as long as you don't mention a parameter that wasn't passed, things will be fine. So if, for example, I only pass the required parameter group, I've got 4. Any processing that relates to 5, 6, 7, and 8, the API doesn't do. And that is how you can make sure that programs that use these APIs or enterprise services don't crash if you want to enhance and add parameters. The important thing is you must add parameters at the bottom of the list, and you must add them as optional parameters, and you must code your enterprise service to check for them and process them only if they're there. Otherwise, to ignore that extra functionality that was applied by the parameter. Different values for an existing parameter is not a problem. You can add new values for an existing parameter without a problem. But it's when you have additional parameters that you need to actually code for that inside your enterprise service. Now, this particular API lists objects in a library, lists objects of only one type, and so on and so forth. It has a specification as to what it can do. And here is where we come to a trick that can be used with your enterprise services as well. Qualified user space object is the first parameter in this API. There it is there, qualified user space object. What this is the name, where am I now? Here. Is the name of a user space. Now, I'm going to be talking in detail about user spaces and user indexes in the next topic. Whether we get onto that today or have to wait until Thursday, I'm not sure. But the qualified user space object, first 10 characters contain the user space object name, and the second 10 contain the name of the library where the user space is located. Typically, temporary user spaces are written into QTemp. Permanent user spaces you have to watch out for because they exist and they could be duplicated and so on and so forth. Generally, they are in QTemp. And with a list API, and this is the big issue, with a list API, the output from that list is placed into this named user space. Qualified user space object. The output from a list type API is put into a user space. Now, I'll show you later how you can manipulate a user space, but understand that a user space can contain a single block of information. It can contain a list of different records of information, which can be a variable length. It can also contain the first piece being a block and the second bunch being a list, which is what happens in this case. It's very flexible, and really its uses are limited to your own imagination. So the qualified user space is actually the target for the output of this call to the API. The next thing that usually comes in with one of these list APIs is the format name. This can be used in your enterprise services very, very successfully. And I choose this particular API to demonstrate this because it gives you a good idea of what can be done. This format name carries values like this. They are formats. It's a standard naming convention that IBMI uses. OBJ, L comes from OBJ, and the L is the list. So OBJL is the object list, 0, 100, 0, 200, 300, 400. I've never seen them slot something in between, but that's the concept. And that particular format naming convention of 8 characters is used throughout IBMI's API list from beginning to end. The numbers change, the letters change, but the same standard format name exists. Now, if you specify the first format, you get a list of object names, which obviously is the fastest because it's dealing with only a list of objects in that library. If you go for the second format, you get text description and extended attributes for each object in the library. And then 3 is base object information. 4 is creation information. 5 is save and restore information and journal information. 6 is usage information, and 7 is all object information, which is of course the slowest because it's picking up all the information for a particular object. Now, taking this concept and applying it to an enterprise server, you can have different formats. You can have one enterprise service program or service procedure which receives a format name and returns different types of information. Let us just use as an example a customer master file, for example. Simple, straightforward, conventional customer master file. You might have your first format, which only produces the customer's name and the contact telephone number. Nothing else. That's what is returned for one or more customers, depending on how you select them. You could have a second format that produces the customer name, its telephone number, the contact name, his email address, and a list of all physical and postal addresses that are listed for the company. You could have another format which produces the basic information about the customer, but also his financial status, his balances, his age analysis, etc., etc., etc. You could have another format that produces a list of all outstanding orders for that customer, and so on and so forth. So you could have one enterprise service revolving around the set of customer files that could produce different results depending on a format name. And these format names they all go into one central procedure call, but then based on the format name, the calls can go out to separate procedures. So each of these different formats can actually be used to call a particular procedure through a control procedure. So you call one control procedure, define the format, and it goes and does whatever that format is specified to do. Now, this is a concept that is used throughout the IBMI APIs, and I firmly believe it's a very, very good practice when you are thinking of enterprise services, because it means you can add function very easily simply by adding a new format name and a new procedure. Existing programs will not be using the new format name. You don't have to recreate them. Only those ones that need the new functions would you need to modify. So you can add parameters to enhance the procedure's functionality, and you can add formats to enhance its output capability. And in these procedures, what is very powerful, because you are outputting to a user space, where did we put it? A user space, which we will talk about in a lot of detail later. You can actually embed SQL here hugely effectively and output a whole set of records in one I/O into the user space based on a data structure that is defined by the format name. As a result, you can get highly efficient. This is where SQL really does have a great deal of power, of hauling out information from a set of database files and putting it into a space where it can be processed. So definitely this as a list method, and you can use the qualified user space object not only for a list but for any type of output. Now let's just have a look. The other parameters, object and library name. Okay, this says what am I going to be extracting. So here now, the first two were what do I want and where am I going to put it? And then here, object and library name. First 10 characters, object name. Second 10 are library. And of course, you have all the defaults. So you can specify generic objects. You can specify library list, all user, everything like that. These are the beginnings of the selection, which you might want to do in your enterprise service as well, to select sets from your files. Here, object name and library, object type. These are the 4 parameters that are defined initially. Qualified user space object saying where the result is going to go. Format name saying what the result is going to look like. And object name, library, and type to say which objects I want out of this API. Now, change objects to customers or objects to products or objects to anything. And you can begin to see how powerful this type of concept is. You might find some IBM I APIs that you can use to great benefit, but I'm emphasizing the fact that their structure and methodology is a good template framework for your own enterprise services in your own application. And why? It's simple. These have been around for 20 years. They haven't changed much. They get a few extra parameters every now and so often when somebody thinks of something new to do with this particular API. But other than that, they are pretty stable. They produce the results. They only need to be tested until they're working. They can be used across the board by any other application that wants to use them. The whole concept is exactly what the enterprise service procedure is all about. You could, if you wanted to, write each one of these as a separate procedure and have a separate procedure name and drop the format name. That you could do as well. But it won't do you any harm to look at the concept behind all of this before going into starting to design large numbers of enterprise service. Right. What is also held in the documentation here is obviously there are descriptions of the other parameters. I'm not going to go into those because these are, just let's look at this authority control format. You can see this is a structure. This parameter is a structure. and it allows you to specify a structure and object authorities in an array that you wish to select. So it's a selection parameter, but it's structured as a data structure with multiple fields in it. I'd suggest you try and stay away from this type of parameter in your enterprise services. Why? Because you want your enterprise services to be as easy as possible for the developers to use. You don't want to make them complicated. You want to keep them as simple as possible and as standard as possible so that they are easy to use. And this is quite simply a message to all senior programmers and program managers. The hardest thing that you have to do is to get a large group of programmers all to go in the same direction. And I'm sure I can see smiles on a number of faces, even though I can't see your faces. There's one guaranteed way of getting the programmers to work in the same direction. And this is not being critical, but a good programmer is lazy. I'm lazy myself. I'd like to do as little work as possible. In fact, my entire career has been focused on trying to find a global solution to the world's problems where I can actually sit with my feet on the desk and do nothing. And because programmers are lazy, the easier you make it for them to do the right thing that you want them to do, the more likely they are to do it. If you make it too complicated, they will do it some other way that they feel is easier. So the focus in developing these types of things is to make it as easy as possible to use, to find, to reduce the number of lines of code, and to make it the easiest way to go, the path of least resistance. In that environment, your programmers will follow that path, and everybody will happen to be going in the right direction because it's easier than not. And that is true, unfortunately, but it is true. Okay, let's have a look at what they put in place here when you get here, you get a format of the generated list. Now remember, this is a list generator, and it's generating a list into a named user space. So that named user space has to have some sort of structure. And in the case of generated lists, and all generated lists, and I stress this again, all APIs that generate lists have exactly the same structure in their list. They have a 64-byte user area at the top of the list, at the top of the user space. That is to allow the user application to put their own information into that list and pass that list on to somebody else. Great idea. They have a generic header, and I have somewhere got a layout of the generic header. It's not here because actually the generic header is common to every single list API that's out there. It contains details of, hang on, now I am wanting to find my generic header because I must show it to you rather than talk about it. Here we are. This is the generic header. There's your 64-byte user area. The size of the generic header, i.e., the number of bytes that makes up the whole generic header. You use this to step over the generic header to get down to where you want to be in the user space. The structures, release, and level. Format name. This is the name of the format that you gave it. Which API was used, the date and time that it was created, etc., etc. Then you have the size of the user space used, offset to the input parameter section. Remember, I've harped on pointers and offsets to pointers. This is the offset to the input parameter section based on the first byte of the user area. This is the size of the input parameter section. This is the offset to the header section, which will probably be 64, because that takes you to there. Offset to the list data section, i.e., this is the offset to the point in this user space where the list data starts. The size of the list data section, the number of list entries, the size of each entry, the CCS ID, country or region ID, language ID, subsetted indicator list, and a reserved 42 bytes, bringing it to 150 bytes altogether. That is the generic header format 0100, which was and has existed forever until they brought out version 7.3, and they decided they needed a bit more space because of some of the APIs that are called as procedures exported from ILE service programs. And so everything from the 100 format plus the API entry point name plus another bunch of reserved space. That's the 300 generic header. So we have a generic header. Then we have an input parameter section. Now the input parameter section is essentially a list of all your input parameters that were used to create the list. Now obviously, I mean, there you can see format name, user space name, object type. And so these are all the parameters that were used to create the list. Don't have to do anything with it. You can step over it if you want to, because you can use the offset or the length, and you can step over it by adding it to a pointer. But it's simply to identify what parameters were used to produce the list. And then you have your list data section. And notice this list data section, this one is particularly OBJL0100, i.e. this is what a list entry looks like if you used OBJL0100 as the format name. Object name used, object library used, and object type used. So that's what you get back. A list of objects, the libraries, and the types. That's OBJL0100. Format name. And you will find the first list entry in the header section here, offset to list data section. There's a number, which is the offset to the list data section, to the first byte of the list data section. You will take that number and you will add it to the address of the generic header, i.e. the user space that you've defined. The user space that you've defined has got a pointer. You'll see that on Thursday. And that will give you a physical pointer address to the start of the input of the list data section. Then we also have in the list data section, whoops, sorry, got the wrong one. We also have information as to the number of list entries and the size of each entry. So how do you move down the list of entries? That's easy. You do a for loop based on the number of list entries, and each time you finish a list entry, you add the size of each entry to the pointer, and that moves the pointer down one entry at a time until you have consumed the full number of list entries as provided in the header. And let me tell you something, you use that instead of an array, it is 1,000 times faster than any type of array processing. So the list data section for format 100 contains those three. For format 200 contains everything from 100 plus these as additional. 300 contains everything from 200 plus these additional. And so it goes. Sometimes some formats don't include everything from the previous format, i.e. they stand alone. But very often that's not the case. Most often, every format lower down carries everything from the previous format plus a bunch more information. And that is how a list API is actually managed within the IBM I. I'm just going to stop here for a second and take a drink of water. Are there any questions at this moment? If there are, please give them to me. Okay. No questions. Of course there are not any questions, because the thing here, if this is new to you, this is something that needs a little bit of practice, and you need to either use the APIs if you have a need for them, or at least examine them carefully so you can base your own enterprise services on the concept. The concept, believe me, is good. Sometimes these APIs have a lot of parameters, and sometimes they have a hell of a lot of parameters. I'm going to show you one in particular, just for fun. And this is the one that, in fact, AO uses the most of. It's a retrieve, i.e., it doesn't bring back a list. It retrieves a single set of information. It also places it in what they call a receiver variable. It's in the database and file APIs. File APIs. There's an API here called retrieve database file description. It uses a thing called a receiver variable. It doesn't return a list. It returns a set of information. Now, AO uses this particular API to retrieve information about files, both physical and logical files. The biggest data structure that you can define inside RPG at the moment is 64K. If I'm wrong, please somebody correct me. 64.767 is about the biggest data structure, and that's not big enough for the amount of information that can be returned from a retrieve file description call. So I actually return it in a user space, which I designate using a pointer as the receiver variable, so that I can have up to 16 megabytes of information returned. And so far that has proved to be enough. But you will see there are only 4 formats in this API. Don't be fooled. The first format, this is FILD0100. And if you look at it, every one of these boxes is a section of the returned variable. And where you get double pages like this, that indicates that this is a recurring section and could recur n number of times. And this is the first. This is the file definition. Goes from there to there. So this is returning a massive amount of information. Now, I can't see any system, enterprise service, ever wanting to return this amount of information in one pass, calling. I mean, remember, this is on calling one file out of one library, and it returns all the information about that file. But your application may have a need to return masses of amounts of information, depending on what type of application you are running. So you can construct the return variables to contain any amount of information that you want. And this is now the detail of that file definition header. And you will notice when we get a bit further down, because it does rather go on a little bit. But when you get down a bit, you will find that you start getting offsets. Offset from the start of the FDT file definition table to one section. Then there will be an offset from the start to another section, and an offset from the start to another section, and so on and so forth. So you are constricting your output so that you can hop from one section to another, and it's all based on pointer and offset. And this is why, in order to make this work successfully, you've got to become totally familiar with the concept of a base pointer and an offset to give you a different position in a data structure or some sort of user index. And this goes on and on. I'm not going to even bother. The first is the biggest API that actually is available. It brings out all the file definitions and every piece of information about the file. Much more than you could ever get from any CL statement. So it's worth looking at. It's definitely worth going into the knowledge center. And I know, I can hear you all saying, when am I going to have time to do this? To go through list database file members. That might be a useful thing for your app. I don't know. It depends on whether your app uses file members. But remember, you can't have multiple file members in a normalized database. List database relations. These are all sorts of things. And if you go back again, of course, you've got different types of APIs. You've also got APIs that do things like close a database file, open it. You can actually open a database file using an API. Or we have a built-in function that does that, makes it much easier. So in some cases, there are duplications with other methods. And in some cases, they're not. And it is these APIs that have allowed me to abandon CL as a programming language. I don't need it anymore. I have written a procedure which allows me to run commands very simply from within the RPG code. I think I actually put it into the open source here somewhere. It's not there, but it'll be here. I actually added it. I'm going to publish it as open source. Give me an example, Dean, of what you were referring to. Okay. Because there are quite a few that anyway, let's see if we can get some detail on that. Even if it, Dean, even if you just send me an email and we can pick it up again next session, if it takes a bit of time, we don't have to do it right now. The command, by the way, I've written it into this, and I'm actually going to publish it as open source. It's a simple thing. There is an API called qcommand-exec, qcommand-execute. This allows you to pass a variable size string, command string, and follow it with a 15p5 length. And this is an API. qcommand-exec is an API. And it will actually execute that command on behalf of the RPG program from within the RPG program. But I found it a little bit tedious because I had to then work out the length of the command and all that sort of thing. So I changed it. I defined another command called CMD, just to keep it simple. I gave a variable 4096 length parameter to it, which is varying and variable size. So this is a varying, it's a varchar. And then the actual call passes me the string, and then I do an execute command, calculate command length of command, and return. It's a few lines of code in a little service program. Well, the one that I use is in my objects handler. This one is in the utility services service program. It is so few lines of code, and yet when you want to execute a command, which I did the other day in one of these, where was it, that test, that DB test. There's the definition of the command prototype. And that is the way I execute CL commands in RPG. And the point is I can either hard code them like this. That's what the constant is. Or I can concatenate the string with variables. Still execute using a CMD call to the command processor. So this is how I execute commands that don't return information. But any command that uses a retrieve and is required to return information, I then build my own little API or enterprise service procedure, call that. That will then use an API to get the information I'm looking for and return it to my program, probably as a user space. It might return it as a single variable. It might return it as a data structure, depending on what is needed. So I have got around the need for using CL and calling CL programs because I found at the time CL was a bit limited. CL is less limited now than it used to be. But nevertheless, I've lost my CL skills, and I stick with RPG, which helps people to be consistent as well. All right, I am going to, we're 9 minutes short. I've got to a logical breakpoint. Kay, I apologize. I didn't get onto user spaces and user indexes. Kay is not going to be with us on Thursday. She's taking a holiday. Jealous, but still, what can I say? But you'll just have to sit and listen to the recording. We will look at the user spaces and user indexes in a lot of detail next week. Oh, sorry, not next week, Thursday, because these are replace a lot of the other objects that we used to use and provide a massive amount of high performance efficiency with simple code from your programs. And I've got a couple of example programs, and I will just get you as comfortable with these two particular objects as possible. Until then, thank you for your time and attention. Do appreciate it, and have a great day. Dean, if you can just send me an email, I will pick that up and we'll discuss that as well on Thursday. Thank you. Go well, guys.